The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, thank you for joining us today. What's new in PMM2, presented by Michael Coburn. Michael is the product manager for Percona monitoring and management. We will begin in just a minute. I was just hoping, could someone just raise your hand using the hand icon in the control panel to let me know if you can hear me? Anyone? Can't see any hands at the moment. I just want to be sure that I am. Any of the organisers want to let me know they can hear me just in case?
I can hear you, Rachel.
Perfect, thank you very much. Right. During this webinar, you will all be muted, but we welcome any questions which should be typed into the questions window. We will answer as many as possible at the end of the presentation. So I'll now pass you on to Michael Coburn, who very kindly let me know that he could hear me. Thank you, Michael.
Thank you, Rachel. Welcome, everybody, to our webinar, where we'll discuss what's new in PMM2. So just to give you guys some color where we're at right now, my name is Michael Coburn. I'm the product manager for PMM, Percona Monitoring and Management, as well as Percona Toolkit. I come from a technical background. I was a DBA before Percona. I started as a MySQL consultant, worked as a manager on the consulting team, and then in the last 3 years, I've been working as the product manager. So as we get towards the end of this discussion, I'm happy to take any volume and technical level of calls, whether they're basic, how do I use the tool, or if you want to go deep about some MySQL internals. I'm not as strong on Postgres or MongoDB. MySQL, I'm certainly very comfortable, so happy to take questions towards the end. Okay, so just to give a little bit of background of what PMM is and why it matters and what does it do for you. It's an acronym. It stands for Percona Monitoring and Management. We've focused more on the monitoring side and less on management, but towards the end of this presentation, I'll show you where we're starting to make our first moves side. It is free and open source. That's the commitment that Percona is making to the market, is that we will remain open source, and PMM stands true to that. We're licensed depending on the tool that's involved at different levels. There's some Apache license on the client side, and AGPL version 3 on the PMM server side. But again, those are open source licenses, so use it as much as you need to while respecting the conditions of those licenses in your environment. PMM is designed to work for the MySQL and derivatives, of which MariaDB is now a fork, for MongoDB and PostgreSQL. So we'll help you whether your environment is only a handful of servers or tens of thousands of servers. PMM can cover those technology size of environment. It's based on giving you a historical time-based analysis of both the metrics, so think in MySQL things like threads running or number of connections, and also the queries. So which queries have run the most, which ones have done characteristics such as most reads from disk, etc. All of that is plotted over time, and we give you a view of how those characteristics have changed and maybe what you should do about it. Okay, it's designed to be used on-premise or in the cloud. It works with Kubernetes, and it can work across cloud providers. So this tool is agnostic in the sense of it's not bound by any conditions of a single cloud provider. But I will mention also that we do have extended or enhanced support for Amazon, which was the first cloud provider we were. Their CloudWatch API metrics to enhance the value of these dashboards. And I'll show you some screens of that in a minute. Okay, so what have we changed in PMM2? We've spent the bulk of our time, I think, on what the killer feature is, which is query analytics. We've made it faster, and we've added the ability to use filters so that you can start at a higher level, show me all the queries running in my environment, and move down to say, well, I care about this cluster of servers or this group of servers, or back down to the individual level as you used to have in PMM1. We also added query analytics support for PostgreSQL. This rounds out Percona's offering around those three technologies of MySQL, MongoDB, and Postgres. We offer the same in terms of dashboards, not necessarily the same count of dashboards, but the same feature parity of support, and then also equivalent within query analytics. We're offering PostgreSQL above the existing MySQL and MongoDB support that exists. I mentioned quickly about the filters. You've got the ability when you set up these servers, your instances, to add arbitrary tags. And I'll show you some examples when we get into our query analytics demo. But the point is that with these tags, you can then customize and group your servers based on what's important to you. So we can talk about things like environment, which might be generic across multiple users of the product, production, development, etc. But you might be in only certain availability zones, or you might want to use some custom tags such as rack values. It's in rack 42 or something to that effect. So I'll show you in the demo some of these different, just to kind of improve the quality of the demonstration. A couple last things. We've got new service level dashboards. It's changed our navigation a little bit, and I'm very, very eager to hear some feedback on it. I've heard some people that are loving it and some that find it a bit cumbersome. I'd love to hear your specific experiences though as we get towards the end, and I'll give a demo on the service level dashboards. And finally, we've improved the security around this. Percona is on secure by default. So two main things we've done. We've enabled TLS between the exporters and the server. That means anything on the network will now be encrypted by default. And we're also putting a username password on the exporters. And so what that means is your metrics data won't be able to get leaked out to anybody who just sees the open port and tries to scrape it, okay? So just continuing on the vein of what PMM is, both in PMM1 and PMM2, there's two components. There's the server, where the bulk of the activity happens, where the resources are really allocated, and then there's a client. On the client is where the exporters run and the query analytics agent runs. And generally, if you have host level access to your server, you'll install the PMM2 client package, which is available for Debian or RPM-based installations, or we also provide tarballs with the binaries. But the point is you'll run these agents or exporters local to the database server you're monitoring, and they will then coordinate with the PMM server to push and pull metrics as needed. If you're running in a database as a service environment, perhaps you're using exclusively RDS or Azure's SQL service, MySQL service, you can still use PMM. You won't need to install any clients. You'll do all of the work through the PMM server through a wizard to add these remote instances. But again, the provisioning of it is that you generally configure the PMM server first on some dedicated, you install the clients one at a time into each of the environments. I'm sorry, into each of the database servers you want to manage. Okay, so we'll take a look at query analytics here. Why do we do query analytics at all? Well, it's going to help you in terms of speeding up the development process at your environment. Well, that's going to give you a way of talking using the same language between your developers, your sysadmins, and your DBAs. Why? Both as a consultant and as PM for this project, is that engineers come to the table with their perspectives of how a problem is presenting itself, and they'll generally use different tools to explain that. Tools that make sense to each of them, but may not make sense to the group as a whole. So what I like about PMM in this case is that we can pass a single URL, and you can have everybody looking at the same set of data at the same time, phrased with further adoption and usage of this tool in your environment, whether it's in production and ideally also in your pre-production environments, development or staging or whatever you call them. Your developers also build familiarity of looking at this data. And I'll show you some of the key points of it. But at a high level, you'll not only be looking at the queries that are running, but you'll get data around the queries. So looking at MySQL, for example, you'll get the create table, you'll get the table statistics, etc. Query analytics, queries that are consuming the most amount of time, that's its default view. We group by the query abstract and then do some arithmetic, some sums to calculate. But this is not the only way to look at it. We've added some different ways of grouping by. So you can group by the client that is generating the queries. Maybe you've got tens of hundreds of application servers, or you can change it to the username that's logged into MySQL and see which username is consuming the most resources. Further, we've got additional columns. Maybe you want to look at the number of disk reads done by InnoDB and sort by that. That's now an option that's available in Query Analytics. So we can do more than just look at the queries themselves, which are slow based on time. We can also look at other activity, maybe the number of locks that they're generating or lock wait time, different characteristics such as that. Okay, so at a high level, I'll go navigating through this in just a moment in the demo, but we're looking at the dashboard right here. This is what's new in PMM too, is we have the concept of filters, little check boxes, and you can select multiple times, perhaps different clusters you want to look at the same period, or in my case, I'm looking at just a PXE cluster of 3 nodes. And then on the right-hand side, the queries refresh, and they offer us the query abstracts, and then in the load column, this is what we're looking at, our spark lines. We're showing how the characteristics of this value have changed over the last, in this case, it's a 12-hour observed period. How have those data points gone up or down over that range of time? And I'll talk about the other headings as we get into it. Okay, I talked about that you can add these additional fields. What that means is you're able to add things like InnoDB read operations, read weights on disk, temporary tables created, etc. Any field that's collected from your data source, whether that's log performance schema, the MongoDB query profiler, or the PostgreSQL pgstat statements. If there is metadata in there, we can then add it as another column, and then you can sort by it, which was a big limitation that we had in our last version. I mentioned already the filters. You can do multiple selects on these filters. And then the group by is really neat. I'll show you, this is what we're showing is in this image here. Instead of it grouping by query by default, you can choose to show which schema or database is also maybe the busiest or creating the most amount of load in your environment. Okay, so some of these new categories in our filters, some of them are what we call standard and others are custom. So some standard ones are the environment, the replication set, and some of the custom ones, like I mentioned earlier, could be something like what rack do I have this server installed in, maybe a data center name, data center equals. They are just arbitrary key value pairs that you can use, and then they appear in the filter list along the left-hand navigation. Through that way, you can then take a look at a larger grouping of servers, they might even be cross-technology, and identify characteristics about that environment through a single filter. I want to just mention again that we added the PostgreSQL query analytics component using pgstat statements. It's easy to use. It's just a view, a materialized view that you can select against and plot the data over time. But the trade-off is that this data source has already done some arithmetic, some average and other types of calculations for us. So as I get into the demo, you're going to notice that it's a bit shorter in terms of row counts, the data that comes out of pgstat statements, and also that there isn't the cool little widget of 99th and average values are, because it wouldn't be accurate mathematically for us to calculate averages on top of average and et cetera. So I'll show you that in just a moment. Another important component of what we added in PMM, switching gears and back to other components other than query analytics, we now have an API, an application programming interface. And with this API, you can add and remove instances and servers. So for those of you using configuration management, whether it's Ansible or Chef or Puppet or some other technology, you've now got a way that you can do curl calls and make modifications against the PMM server. And where I think this is really useful is in more dynamic environments where servers are coming up and going down frequently. You know, you don't want to be doing any of this stuff manually. And if you can build it into your orchestration tool, then that makes it that much easier to clean up and provide some sort of a life cycle management for your monitoring system and your databases as a whole. We are using Swagger. I come database background, so I don't truly know why this is cool, but the developers tell me mention it. And I did that at the Percona Live conference a couple weeks ago, and I actually got a round of applause. So I guess Swagger is important, and that's what we're using. So I mentioned earlier about the security improvements. We are encrypting by default on the wire, so all of the communication is encrypted. Of course, we do trust our internal networks maybe more than the public internet, but maybe they shouldn't be trusted fully, and that's the fault that Percona is achieving here, is that we're just going to encrypt it wherever we can. Okay, and I mentioned also that we're password protecting the exporters. What that means is it's got a random username based on the, I want to say the service ID or the node ID, some sort of very long UUID value, and then the password is randomized per instance. You may only need this if you ever need to do some troubleshooting to actually get access to these exporters and scrape them. If you're testing for, perhaps working with Percona support to identify maybe there's some firewall or some other routing issue in between the PMM server and the client. But by and large, you don't need to access these exporters. This is something Prometheus PMM server does on your behalf. Okay, this is where we get into some of the more UI and significant changes beyond the query analytics improvements. We've changed the way the navigation works. So we're still maintaining a home dashboard, which gives you a high level, what does my entire PMM server collection of instances look like? It gives you things like the CPUs, the network throughput, you know, how many queries per second, if that makes sense, depending on the technology, et cetera. It gives you just a bunch of little boxes to tell you the health of your environment. From that, this is where we've changed it a bit. Whereas before you used to have the ability to click through to any technology and sub dashboard. So for example, I could go from the home dashboard right to the MySQL InnoDB metrics dashboard. Instead, what we've done is we put a layer in between, which we call the instances overview dashboards. And what this is designed to do is per technology, so there's MySQL, there's 4. So there's MySQL, PostgreSQL, MongoDB instances overview, and also a nodes instances overview. 3 are the ones that we've talked about service level. So this gives you the health of the cluster of servers. And finally, the node one gives you the system level metrics, things like the CPU, memory, disk throughput. And that's predicated on either the availability of node exporter running locally. Node exporter is designed to capture data out of the proc file system, so CPUs and how they're looking. Or if you're using Amazon RDS or Aurora, we have the integration with the API, with the CloudWatch API to fetch those metrics as well. So that's why we've got the 4th category of node instance overview. Just a quick 3 more, and then I think we'll get into some of the screens. The compare dashboard is designed per service to show you servers side by side. And I'm going to show an example of where this is maybe significant using PXC. In PXC, generally you want to configure your servers the same, because they're all technically able and expected to handle the same level of workload. So having a misconfiguration between them could be problematic in the long run, and that's what compare is designed to do, to show you performance side by side and some of the server metrics, server variables as they're defined side by side. Summary is the lower level one at a time instance view. So in this case, we'll look at the MySQL summary dashboard for a single Percona Server 8 instance, and it'll show us things like number of connections, number of temporary tables, kind of a high level view of it. And then details. Details is where we get into specific, not only technology, talking about MySQL, but also a low level feature. So the details dashboards are around the storage engine. We've got one for InterDB, which has been redone. We've got one for my ISAM area, if you're running that, one for MyRocks, for compression, a whole bunch of technology-specific details dashboards. So looking briefly at the instances overview dashboards, this one here is we're showing 5 different services that are collected within MySQL. I'm running 5 MySQL instances and showing some highs and lows on which servers have been up the longest, and queries per section for the whole environment. The compare dashboard, I'm showing 2 servers side by side. It's showing things like system versions. That would be a big, I would say, a call out for either our support engineers or for you to make if you are running disparate versions, for example. Showing the size of the buffer pool, again, that would be a cause for concern if you had differences there. And also the queries per second. On one server, I'm showing just shy of 90, and the other just over 400. That might be something worth looking into. In my case, I know it's because the PXC 571 is the writer, and it's in a different proxy SQL host group than PXC 572, which is in the reader host group. So I can explain that away, but I would expect you looking at your environment to say, oh, why do I have such a tremendous difference perhaps in my queries per second or database connections for the same reason? The summary dashboards, I think we've seen quite a bit in PMM version 1. Again, I talked about how the thread activity is here, the number of connections and threads running, how many queries per second are running, it's answered by the MySQL questions graph, components like that. And then finally, I'm showing the InterDB dashboard here. This one was recently redone by our CEO, Peter Zaitsev, and it combined what used to be known as InterDB and InterDB Advanced dashboards into one dashboard. And so here we're using a mix of graphs that show values over time, which are the lower ones starting with InterDB rows red, InterDB row rights, and then above that are what are called single stats. They're showing you some value over a much shorter period of time, a single point in time. What is the integer, or in this case, I guess, the float 64 for some of these values. Okay, so we'll move on to the demo here. Oops. Let me take us over to our home dashboard. I mentioned earlier that we have, wait for the screens to catch up. There we go. So I moved over to the home dashboard. This is what you see as soon as you log into PMM server. This is a PMM2 server. I'm running the original GA release. We have had a 2.01 bug fix come out, but so I haven't upgraded it yet. But should I be ready, and I've disabled it in this widget because I don't want other people to apply changes to my demo environment, but I could just click a simple button here and it would run, it would pop a box and show me progress, and it would run for maybe 5 or 10 minutes, and your PMM server would be upgraded to the latest version. So in-place updates within PMM2 are very simple, just by clicking a button and waiting a bit of time. After this runs, you'd need to go out then to each of your clients using config management or what have you, and upgrade those PMM2 client packages as well. So other than being able to do upgrades from this home dashboard, I'm able to look at the different environments that are covered off here. I'm sorry, servers in my environment. So in my case, I have a roll-up of all of the servers, their total amount of CPU, how busy they are, queries per second, how long they've been up, etc., and how much RAM I've allocated to my environment. I've found this useful. Some customers have told me that they had no idea how many CPUs and RAM they'd actually provisioned for their environments, and it's helped them control some of their spend. So they were able to go back and say, reasonably, we need half of those resources, for example, in production. And they were able to spend some time calling out machines that either were over-provisioned or just not doing any work, because this brought to light, rather than just looking at their AWS bill and saying, well, from an abstract host name, the value of the server, PMM gives them the context to make decisions based on spend. And so as I scroll down, I've got some, one of the new features of PMM2 is that we've upgraded to Grafana version 6, and that means that these dashboards only load values once they start to appear on the screen. And that's a performance win, so that we don't spend time querying the backend server for PMM server needlessly. So if you're not going to scroll down to look at values lower, there's no need to run those queries and incur the read penalty on the PMM server. Okay, as I transition, I go over to the nodes overview. Oh, I'm sorry, I'll show that quickly where those links are here. At the top, I mentioned that we've changed our way of navigating. And so now what we've got are these instance overview lists: MongoDB, MySQL, Nodes Overview, and PostgreSQL Instance Overview. I've gone directly to the Nodes Overview screen. And in this case, we have 16 hosts provisioned. And so it's reflecting the total count that it's identified. How many of them are running databases, number of CPUs altogether, things that we saw in the environment overview. But this gets into a bit more of a split. How much of those servers are waiting on disk? That's an interesting characteristic. That would lead me to believe that in my case, I'm either driving the disks too hard, or I haven't provisioned high enough quality. If I'm spending 45% of my time waiting on I/O, I've probably got some servers that are performing suboptimally here. So this dashboard is designed to give you, again, high level, what are my 16 servers doing in some, in a lot of cases. And in individual, what are my minimum hosts that have been up? I had one server got rebooted less than 2 weeks ago. So that's usually something I wouldn't care too much about, but if I saw something rebooted within the last day, that might be somewhere for me to spend some time drilling into to discover which server just got restarted. Okay, going to the instance overview on MySQL side, it's similar to the nodes overview. In this case though, it's all MySQL specific data. How big is the buffer pool in total for all of my environment? But I'm sorry, I've only selected the PXE cluster. Let me change that. So for all of my MySQL instances that I've actually got 2.5 gigs or 2 3/4 gigs worth of buffer pool size. I'm doing 2,000 queries per second, but if I focus it just on my PXE environment, it should be something less than that. So just over 1,000. Is that you can then filter down to different replication sets, clusters, or even just down to the single node to look at individual servers and services. And in this case, we're getting MySQL specific information. We go over to the instance compare. I mentioned this earlier about the value of looking at PXE side by side. I had already highlighted that there was a difference in queries per second. This is in one host group that is designed for writes only, and these other reader host groups. And that's good that I see equivalent values for these two, fairly close, 503, 501. Similar number of database connections and much less on the writer node. That's good to see. And where it starts to get interesting is have I configured my buffer pool size to be equivalent and as a percentage of total RAM. So in this case, 64 megs is consistent across all three. And also I've provisioned my droplet size of DigitalOcean the same. I've got the same percentage of the total RAM allocated. I probably should increase this greater than 64 megabytes. And as we're comparing, it not only gives you some of these static values of what we've defined for buffer pool size, for example, but also performance characteristics. So now I can plot MySQL connections or client thread activity side by side. And again, because I'm in two different host groups, this is the one on the left in the first column, server 1, is going to have different characteristics than server 2 and 3. So I'm looking for similarities between 2 and 3 in this case. I'm seeing consistent similarities for thread cache, for MySQL questions as they come in. So this is a good dashboard for me to kind of just give a thumbs up that my environment looks like it's working properly. In this case, in PXE server 573, I disabled the slow log. I'm fetching query metrics from the performance schema. So that just, I hadn't noticed this before in prior demos, but I have slow queries appearing for one because server 2 is being written to the slow log, but server 3 is being written to performance schema. Drilling down a little bit further, it's the MySQL instance summary. This is the view that we used to start users off when you're looking at a specific technology. So in this case, what you're looking to do is select a node that applies to you. This list is pre-populated based on the detection of MySQL as a technology. So it will only ever show MySQL and not show PostgreSQL or Mongo. And then you want to associate the correct service name. The reason we have a distinction between node name and service name is service name allows us to accommodate more than one MySQL D running on a single node server. That's something that applies to us when we're doing some container work, but also some people just run 2 or 3 MySQL on the same physical host to take advantage of all of the resources. So in this case, again, we're looking at things like the number of connections. We saw this on the instances on the compare screen. Connections and queries per second, but we get into some greater detail on how the network is being used and particularly how the memory is allocated. So we can show that the buffer pool has allocated data and also the key buffer in the case of MyISAM. And if you're running TokuDB or MyRocks, you'll also see allocation to those storage engines as they contend with the buffer pool that InterDB has allocated. We can show in this particular server here, it's doing bulk of its activity are selects, but there are some updates running. I'm using Sysbench, and it looks like it's doing somewhere on the order of 13 to 20 queries per second in terms of selects. And I think I've got my updates tuned to 1 or 2 per transaction. So I'm not trying to push this server over the limit or see how much it can do. I really just want to make sure I've got up and downs on my graphs. So I would expect maybe your environments to have a different type of query pattern, maybe not as flat, maybe something that follows the sun or some other sort of user activity, maybe when people are getting home from work or some other characteristic. But the point is to plot the types of COM values over time here. And what we've included down at the bottom, I have the query cache disabled, but down at the very bottom, we also reiterate the node summary so that when you're looking at something, I want to get something too on the same screen here. Let's see. Okay, it's not going to fit very well. What I wanted to show is that we have this concept of this hover, this red line. If you notice that I'm doing it on the CP usage, but it also shows up on all the other graphs. And so the value of us including this node summary at the bottom of the MySQL dashboard is there might be something at the node level, something CP usage or the disks are swapping, and that's what's leading to the MySQL contention, some sort of other slowdown in MySQL. So the point is that we want to make it so that you don't have to bounce to another dashboard just to get a quick glimpse over what the node level activity is for this host. So that's why we include the node summary at the bottom. And then closing out the last of the dashboards before I get on to query analytics. This one is based on InterDB, and it's a rewritten one that Peter pulled together. It's designed to give you some high-level information about InterDB in the top section, and then we get into some detail around the storage of it. How many tables are present, how much space has been allocated on disk, the size of the indexes, how many rows that the database has, characteristics about InterDB that are ideally useful, not only to yourselves as database administrators or developers, but also something very valuable to share with Percona. And I'll show really briefly what that means. At the top, you might be working a support ticket with Percona and we're asking for either additional detail from your environment, something around the InterDB data. We'll ask you for a time range, and you can set that through this slider box up here or set a custom range. And then you'll choose the share button. You'll go to the snapshot, and then there's an option for share with Percona. This will spin for a little bit. It'll give you a URL that you'll then paste into your support ticket, and we'll then be able to access that data. It's disconnected from your environment because these dashboards are simple JSON objects that would get pushed to Percona's a Percona web resource that then is protected by two-factor. What that means is you can paste that link to us, but if you try to do a get on it, if you try to load that URL, it won't work for you. It will depend on a Perconian only being able to do a get. That means that it's protected. Your data never leaks out of your environment. It's communicated over SSL to Percona, and then only Perconians have access to read that data. And why we like that is when we're able to look at the same data as you are, we're able to still drag and drop and drill in a little bit and discover some anomalies and give you some guidance on what modifications you might need to make in your environment. So sharing dashboards with Percona is a really great feature in a way that we can help you close your tickets out sooner and give you actionable information. Okay, switching over to the query analytics. This is, I had mentioned earlier about the concept of the filters that we've added on the left-hand side. We've also got the concept of sorting by different objects here. So I'm going to choose to look at which database is the busiest in my environment. Oh, sorry, schema. Database is a PostgreSQL concept. So in this case, I've got 4, in my PXE environment, I've got 4 different schemas, and one of them is generating about 50% of the load, just over 50, slightly less than 50%. And then two of them are hardly doing any activity at all in terms of time that the server spent doing any work. But let's say I don't want to just look at load. I want to get a spark line of the InnoDB read operations. Now I still have the same schemas displayed, but now I've changed my order. InnoDB3 is actually not doing any read operations. It's dropped right off the map. But some of these other database, schemas are busier. So the premise is I can get a nice little spark line, and I can then sort and change the order of these values, of these schemas in this case. I mentioned earlier we have this cool little widget that gives you 4 pieces of information: the min, max, average, and 99th percentile. Okay, they might make a bit less sense on these schemas, but I'll show you where we also offer those when we look at individual queries for tuning. So for example, I'm still looking at my PXE cluster, and I want to choose a select because they're usually easier to explain away. This query is sorted to the top in terms of InnoDB read operations, and it's doing about all of the disk activity. It's doing about 30% of all that work is from this one select. It's a primary key lookup, but it's probably not in the buffer pool, so it's having to go to disk quite a bit. If I'm looking to talk to my sysadmins about disk quality, this is the kind of view or the kind of sorting I want to bring to their attention. We have 2 queries in this case that generate more than 50% of the work. That's of the work of the drives. Do we need to spend more on drives? And you'll be granted some sort of cost for that. Or does it make more sense to optimize them or change the query, the way the RAM is provisioned, or change the buffer pool size based on just looking at a sorting based read operations? I'll put it back to load just to see which are our slowest queries. And now we've changed it. Now we don't have that select anymore. It's not one of the slowest queries. They just happen to be the one doing the most off of disk. I want to find a select here. Okay. All right. So the query itself actually executes quite quickly. In this case here, let me see if I can scroll over. There we go. This query executes as quickly as 59 microseconds and upwards of just under 1 second, 730 milliseconds. So there is a bit of a range in there, and that might be related more to other system level activity that's going on. What I mean is if the disks get slow or the CPUs get saturated, that's what leads to these max values being quite high. I do concern myself with those as a consultant if I were in to talk with you, but what I'm looking for is the 99th percentile value. So in this case, I'm in the 10 millisecond range 99% of the time or less. So the fact that we have some really big swings to the max might be some opportunity for, again, isolating why we have such high maxes. They're nowhere near what the 99th percentile is. So most of the time, this query responds very quickly for users. So I wouldn't spend too much time trying to optimize the query itself, but I might look into why the max is so much higher than the 9. So anyway, we've selected, we have a select statement that we want to drill into. As we had before, we provide a whole wealth of information about this query when you go down to the query details section. In this case, consistently across all the technologies we report, we've got the number of times the query ran, which is the count, how much time that query took, and then we have the concept of either rows sent or bytes sent. In the case of Mongo, it's document sent, but otherwise MySQL and PostgreSQL use the concept of rows. And then here, these InnoDB values are additional because this is a Percona server, well, PXE. So it's using the Percona server extended slow log format. So it gives us a whole wealth more of information, such as the InnoDB activity, temporary tables usage, locking conditions, a whole bunch more than you get just from MySQL community. And so we're plotting these, showing what the rates per second are. So 5 kilobytes worth of data being sent out of the server for this query, which isn't too much. Overall, it's generated 1.5 gigs over the 12 hours I'm looking at. It's my default. And of that, of all the bytes sent, this query has generated 5% of all of the network traffic. Okay, we noticed this earlier. It's doing a lot of reads from disk. It's generating about 30% of the disk activity. And how much reading from disk, it also makes sense that it's doing most of the wait time. Having to read from disk incurs some penalty. It's not as fast as the buffer pool. And so almost 37% of the time that the database InnoDB is waiting on disk is to satisfy this one query. So again, these are from Sysbench. They're not designed to be other than primary key lookups where there's a value that isn't in the that is an unindexed value. So it generally won't be in the buffer pool. The point is that we can isolate this based on the characteristics logged to the slow log or to the okay. And I'll just quickly look at these filters and then we'll get into just a couple more slides and then we'll be available for questions and answers. So I mentioned earlier that we've got the ability to choose the cluster. The replication set is a concept we're trying to use that unifies the different technologies. So for example, MongoDB has the concept of a cluster, and a replication set is also native to it. So for a proper MongoDB cluster to operate, it will have more than one replication sets, and therefore we'll want to name them appropriately. It's not showing them all right. MongoDB repl set 1 and 2. Database is a concept that's specific to PostgreSQL. It's kind of an object higher than the schema. So we've included PostgreSQL and SB-test in the config. Template 1 and 0 should also appear in this list here. And in terms of schemas, this is a MySQL concept. These are the schemas that are create database is what the actual create table is what schema maps to here. I'm sorry, no, I'm mixing my concepts. Schema is what you get when you do a create database, and that would give you the inner DB2, and then inside that I've got multiple tables, SB-test 1, 2, and 3. This enables you to say perhaps in your environment you've got a schema per module or schema per application, and therefore then you could then do a comparison to see which schema or application might be consuming the most amount of resources. That comes up often when customers ask me, hey Michael, I want to look at some functional partitioning. I've got this one database server that runs multiple applications, and I want to know which of these schemas I ought to move. And using query analytics and drilling down to the different schemas, we can both help optimize the queries that run on them and also decide which ones make the most sense to move elsewhere. Wrapping up, we've got the nodes. If you want to drill into a specific server and see what the queries are running on that machine, you can highlight that. However, one of the cool things when you do select server and you've selected a query and it's displayed in the queries, on the right hand side we've got the same filters but from a bottom up approach. So I can tell you this query doesn't only appear in production but also in development. It doesn't only run in PXC but it also runs in the MySQL cluster. And it also runs on two other servers, PS8 and PXC 5.7-1. So it's kind of a neat concept that using the left over here you can drill down, and then looking at an individual object, you can also drill back up to see how it applies to any of the other potential tags that you might have added. And in my case here, I've created this, made up some strings here. I've added a custom tag of a city that they run in. And these are just some ways that you can extend query analytics to be more reflective of how you've deployed your application in your environment. Okay, take it back to present mode here. And we'll move on to one forward thinking or one forward concept that we want to illustrate within Percona is how we're starting to have our tools work more closely together. And what that means is that with our tools working better together, Percona has been known for our Percona toolkit, Percona server for MySQL, and some other technologies, but they have traditionally been working independent of each other. We're making a big push in 2019 and in 2020 for these tools to better interoperate. And where we've decided to begin with is within PMM, which we've just demonstrated today, along with our Kubernetes operators. And these work so that you can orchestrate a PXE, a Percona XRDB cluster environment in a Kubernetes environment. And what we're going to demo with this is we want to be able to use PMM to identify a problem. For example, I've got high CPU load, I've got a lot of queries per second, my SLA says we can't support more than 2,000 or 2,500 queries on each node. Well, I've got a cluster of 3 nodes, and I know that I want to go home on my Friday afternoon. I don't want to spend all weekend provisioning new machines, etc. What we expect is that through a single button, you can click within the PMM interface, and it will connect to your to the Kubernetes operators developed by Percona, and say grow the cluster size. Now, with PXC, you always deploy in odd numbers so that you can always have quorum. So going from 3 and incrementing the cluster size will take you to 5. And what's happening here is we can see using the glare cluster size, we've gone from 3 to 4, and soon it will go to 5. And what we'll be left with is an environment that has 5 total servers that have also not only been added to the cluster, so they have copies of the data and are ready to take queries, but because you're using Percona's Kubernetes operators, they also include Proxy SQL, which is a MySQL protocol level aware proxy service, which I had shown earlier has the concept of different host groups. You can have one group that has just for the writes going into your cluster, and the other group is for reads, or maybe various clusters that you can move them around. Maybe you have it per application, you want to have a host group per app and move them between different servers. But the premise is that the Kubernetes operator automatically add the 2 new hosts into those host groups. And as you can see, we've achieved 5 in terms of our total counts of nodes in the cluster. And we've also seen our CPU usage drop from around 60% total down to about 40%. So we've achieved a service level agreement. We've got below where we needed to be. And also for our queries routed, we've gone from about 3,500 per server down to about 2,000 per server. So that means you can go into your weekend, you spent a little bit more money because you provisioned 2 new instances in Kubernetes, but on the flip side, you're able to be a little more relaxed because now you've got additional capacity to get you through the weekend and then maybe make a different decision come Monday. But you've been able to kind of click your way out of a problem and hopefully have a smoother weekend than you might have otherwise had. So again, this is just another blush of where Percona wants to be spending more energy, showing how our tools can work better together. Okay, 2 more slides here. So why should you? Well, we talked about this being free and open source. That's Percona's commitment to the community. Whether you're a customer of Percona or whether you're just a user of our software, we will remain open source. We see PMM2 as more of a single pane of glass to help you, not only in on-premise or in the cloud, across multiple different pieces of technology. We know that the monitoring space is quite crowded. There are different components out there and services being offered. But this one is a little bit different, I think, primarily because of our query analytics, and also that because you can see across multiple technologies at a greater depth. We'd like to say that it eventually will minimize the amount of time you're spending managing your database environments because we're integrating PMM with some of our other tools like the Kubernetes operators. They are available not only for PXE, for the MySQL story, but also for MongoDB. We've got PXE operators for that. So we can help you using PMM to monitor and manage those environments. Okay, so this is the last slide. What I wanted to share with you is where you can maybe give back to us. First and foremost, if you're using our products, we love it. We'd love to hear your feedback on that, whether it's good or bad. As the PM for PMM, I definitely want to hear about any bugs you're hitting. We'd love to have you file those in our Jira system, but you can also reach out to me directly. I blog relatively frequently on Percona's site. You can leave us public comments there, or you can write to me directly. But again, the bugs that we want to see those get reported through our Jira system so that we don't lose track of it. If it gets sent to me, I'm usually disciplined enough to log those, but sometimes I miss them. And also, I want to hear about any ways that you're using PMM that isn't maybe standard. If you've extended it using external exporters, if you want to have a conversation about that, I can show you different ways to do it. Maybe different ways to pull in dashboards and how to visualize data. But also, I'd be interested in sharing your story with the greater community. Have an interesting way using PMM, please reach out to me. We can get you published and do some cross publication between your blog and ours. We have the opportunity maybe to invite you as a guest speaker to one of our Percona universities if it's local to you, or even to Percona Live. We're going to be again in Austin, I think in May of next year. So we'd love to maybe have you on site. I do a customer talk every last one was a group from France called Tessie, and prior to that we had Verisure from I forget exactly where. Anyway, we had a great talk bringing in customer stories, and people love to hear about those. So if you have anything unique about how you're using PMM, I'd love to hear from you. And at this point, I'm going to turn it over to Rachel, and for any questions, we'll be here.
Thank you, Michael. We do have some questions submitted. So what I'll do is read each one for you to answer, and then you can let me know when you're ready for the next one, if that works for you. So we've had a very enthusiastic response. So I'm going to start with the first. I'm going to do it in order when received. Okay. So the first question is, how do you create and configure alerts for MySQL?
Fair question. So PMM provides for alerting. The current way of doing it would be to use an alerting platform. And basically what I've done in my environment is I would set up a separate dashboard for alerting. And the drawback to Grafana alerting is that you need to take away the variables that we use that auto-populate some of these dashboards and replace them with strings. But once you do that, if you're managing maybe 50 or less servers, it kind of makes sense. You can handle it by hand. But as you get larger, Percona customer, we have some scripts that some of our engineers have written to kind of automate the development of these dashboards. But the point is that you create a custom dashboard and you configure an alert. Grafana supports, I think, a dozen or so different data sources. I'm sorry, sending channels, they call them. So to Slack or to PagerDuty or to VictorOps or any of these kind of endpoints, SMS, email. Grafana can spit them out based on the conditions and thresholds that are defined in PMM.
Okay. Next question. Does PMM2 show queries that use views? With PMM1, the show create table / explain plan didn't work with views.
I don't know off the top of my head. We did rewrite the query analytics engine, the parsing side as well. I'd ask that maybe you take a shot at it. At the very minimum, we will get the select is occurring on the view, but I'm not sure if it will decompose the view and say, well, this is a view comprised actually of 3 backend tables, so let me show you 3 create tables. We're not at that stage yet.
Okay. How do you enable the edit option in the metric page for trigger alert?
I'm not sure what the trigger alerts are unless they're the Grafana alerting. You would need to be authenticated to Grafana, to PMM server. When you deploy PMM for the first time, the default username password is, and you're prompted to set that immediately. So those would be the credentials that enable the magic to happen. It gives you edit level privileges, or admin level privileges, I should say, through all of PMM server.
Okay. I am using PMM2 brackets Docker method, but failed to do alerts configuration. Please help or share some links related to PMM2.
The alerting should be the same as in PMM1. So we can basically recite I think we had a couple blog posts on doing alerting in PMM1. But to be fair, we are planning to refresh these blog posts and just check where there's going to be differences. But the short story is use what you can do from PMM1 with the Grafana alerting. And in the coming sprints that we're working on, I was hoping by the end of the year, but it might be Q1 2020, we want to be able to ship Alert Manager, which basically means it'll be a much more sophisticated alerting platform. The alerts can be more complex. They don't need to be replaced by these strings. We can still use variables, etc. So watch for Percona over the coming months to really start to tell a much better story about alerting using PMM, because we'll leverage Alert Manager.
How do we control the frequency of manual queries using custom queries module of MySQL exporter?
Great question. So custom queries, to give background, means that if you can write a select statement, you can then generate a metric series. And maybe some use cases where that'd be kind of cool is if you had maybe a users table, this is arbitrary, a users table that tracks the state of your user, whether they're logged in or logged out. Percona and PMM would never have any understanding of what that is. But if you can write that outputs those labels and those values, those get turned into a metric series. And then you can take that metric series and plot it on a graph. Where that might be interesting is that you have a gut feeling that when you hit 1,000 users logged in, MySQL stops responding. Well, then you can plot that on the same graph or side by side with another MySQL connections or MySQL threads running or something, and be able to correlate your user level, application level activity with what the database server is experiencing from a metrics perspective. So that's custom queries, and that's available for MongoDB. It's not available for PostgreSQL. So you can now, based on directory hierarchies, define 3 different scraping resolutions for these queries to execute. And they will follow the high, medium, and low values. High frequency is 5 seconds, medium is 5 seconds, and low is 60 seconds. Whereas before in PMM1, they would only scrape once every 60 seconds.
Okay, and the last question.
And then that hierarchy is defined, sorry, Rachel, just one quick sec. And that hierarchy is defined where you're going to be writing your queries.yaml file, and it goes into the directory user local Percona, I believe Quan agent or PMM agent, something to that effect. And then there's a cascading series of directories there. Okay.
Ready for the next one?
Mm-hmm.
Okay. How do we specifically remove Prometheus monitoring, not only dashboard, but also to stop gathering metrics?
Sounds like this user would only want to track the queries. You can choose to and remove the service, and then the Prometheus daemon. So what I mean is, if you're using the shortcuts PMM admin add MySQL, when you do that, 3 things are going to happen. You're going to start collecting the node level information. You're going to start collecting MySQL metrics, which is the Prometheus side, and then also the MySQL queries, which is the query analytics engine. And so you'll add those services, and then you can immediately remove the MySQL metrics. And that means Prometheus will still run in a daemon mode inside PMM server, but because there's no endpoints to scrape for the MySQL metrics, it just will never attempt to fetch those from MySQL. So you will continue to submit query analytics information. That's what I would do.
Okay, and the last question. Is there any particular reason why we need Grafana admin user and not Grafana read-only or admin user to register DB nodes to PMM?
So it's less about the Grafana admin level. It's more that we're using Grafana's authentication system for all operations within PMM server. And so we need some sort of distinction between admin and read-only so that we can register and not let anybody register or remove instances. So in that case, in my demo environment is I have the admin user, I've reset the password to something that I don't even need to know. And then I've provisioned another admin user, I think I call it PMM register or something. And I use that one when I'm adding up my clients when I do the config operation, when I'm adding them to the server. And then my own Michael Coburn account is also admin level. And then everybody else within Percona is attached to our LDAP environment. And therefore it inherits which group they're in. Pretty much everybody gets dropped into the read-only role, but they can authenticate using their LDAP credentials, and everything remains secure that way. So we, again, just to reiterate, we only need that admin level for registering because that's what authenticates all of PMM server, not just Grafana actions.
Okay, I think we've got actually just one more question came in while you were talking, Michael. So as we've got a couple of minutes, I am going to put it to you. It said, not seen MySQL cluster during the demonstration. Is InnoDB cluster metrics? Any plans to add InnoDB cluster if not?
If what I'm hearing is it's a MySQL InnoDB group replication or InnoDB cluster, I forget precisely how they name it. We do have plans to integrate it. We have actually a couple customers running it in prod. In fact, I don't know what their eventual plans are, but they were pretty aggressive about getting it in. And they came to us, and our consulting team built out some dashboards, and using MySQL custom queries, they were able to extract some of the group replication metrics, create a metric series, and then with the dashboards they created, can then visualize it. So we also had a community member, Valentine Traen, who was at Percona Live Europe and from Tessie, who did the presentation with me on their usage of PMM in production. And he specifically created InnoDB group replication dashboards and published his dashboard that he's got and also the custom queries. So you've got 2 resources. If you're working with Percona as a customer, file a support ticket and we'll share with you what our group replication work looks like. Or you can go to GitHub, and I'll make sure that Rachel and I push out some communication post this conference here, where you'll be able to get those links to GitHub and see Valentine's work, and then you can integrate it yourself. Or the last option is you can wait until we actually pull it into the product. Because we just don't have that much interest in it, this is the first time outside of our customers. We haven't fought to get it put into the product yet, But I would say within the next couple quarters, we'll make sure it's one of those vanilla supported dashboards.
Fantastic. Thank you very much. We've reached the end of our time, and thank you everyone for joining us today. A recording of this webinar will be available on our blog shortly, along with the information that Michael mentioned, if you wanted to re-listen or share with anybody else. We'd like to encourage you to follow Percona's blog for everything open source, and also please save the date for Percona Live 2020, which is going to be taking place May 18th to the 20th in Austin, Texas. Thank you everyone for joining us.